So we are going to draw the Vesper diagram, box diagram, and contour diagram for the molecule NO2. So we know that N has 5 valence electrons and O has 6, giving us a total of 17 electrons that we want to work with. So the Lewis diagram shows us that we have an N double bonded to an O and single bonded to another O, giving us one free radical. Because of that free radical, we'll find that the Vesper diagram is going to have a bent shape because the lone pair bonding pair repulsion is greater than the bonding pair repulsion, giving us an angle of less than 120 degrees. Here we have a graphic of our NO2 molecule. I'm just going to add the lone pairs so that we can see how it really looks. We have our double bond there and our single bond on the left with the angle that is less than 120. Here we have the graphic that is showing the atomic orbitals, and you can see that those two big blob-looking things on the right side represent the double bonds of the nitrogen to the oxygen. This last graphic shows how our atomic orbitals overlap one another. You can see that happening here. So here we are going to start drawing the box diagram for NO2. I've drawn above to show that the electron configuration is 2s2 and 2p3. Those will be the ones that we'll be working with. Those will be the ones that will be hybridizing and bonding. So I'm just going to draw that. And then we have 1, 2, 3. So we have our 2s orbitals filled with 3 electrons in our 2p orbital. So what we're going to do is we are going to hybridize these ones. And once we bring it over here, it's going to look like this. And we're going to have our 1p orbital filled with that one here. And nitrogen over here is in its ground state. And this atom will not get excited, so there will be no excited state for this one. And as you can see, I left 1 p orbital right there, which is going to later form our double bond. Just going to get rid of that so I can draw. Okay. Now I'm going to draw the box diagram for oxygen, both of them. And I'm only going to draw the orbitals that will be bonding, which is the p. I'll draw in a different color. and the oxygen electron configuration ends at 2p4. So we're going to do that. And so what's going to happen here is this is going to come down here. And this one is going to come down here. This one is going to come down here to bond, to form the double bond with the p orbital. And now you'll see how we have a lone pair up here in the p orbital. And then what we're going to do is we're going to take one from the nitrogen hybridization here, and it's not going to bond, but it's going to share an electron with the oxygen, which leaves the nitrogen atom with the free radical, the one unbonded electron. So eventually what we're going to end up with all the arrows and the circles is and this will be our free radical. And in case it wasn't noted earlier, nitrogen is hybridized as sp2 because it has 2p and one s orbital involved in the hybridization. And as you'll see, p is drawn a little bit higher here than the hybridization here, because the original p orbital has stayed the same, so it is a higher energy. Now what we're going to do is draw the contour diagram for NO2, and what we're going to start with is N as a central atom. And then because of the double bond, it is going to repel the other two groups further, closer together and further away from the double bond. So I'm going to draw like this. And we are going to have three sp2 orbitals. And in the one of the sp2 orbitals, we're going to have a single electron, and that's what is going to represent our free radical, which is not going to bond to anything. And our other two, we're going to have the shared electrons, the sp2 orbital with the oxygen, which is going to be a p orbital. And we're gonna label that O. And now, coming from our nitrogen atom, we're gonna show how our nitrogen and oxygen form a double bond. And then we're gonna have another one coming out from the oxygen. We're gonna show 1 electron each, and these are gonna overlap to form our pi bonds. And so now what we have here is 1 bond on the hybridized orbital, and 1 a double bond here with our 2 p orbitals.
The reason why they repel as much is because low pairs take up more space.
Oh, I gotta create a YouTube channel now.
You have to?
I don't know. Do you? You have to have a YouTube channel to upload stuff, don't you? Or no?
I don't know. I think you can just send it
Oh.
to the app.
Oh, okay.
Yeah, no, I used to well, I just like to do that.
You know what I mean? Yeah, that's, you'd have to leave about.
You finished? Wait, let me do it with you because I don't know how to do this. Did you just save it? Save it here.